but Matt's going to present Replicate and Extend, an approach to teaching research methods in R programming. So Matt, the Zoom screen is yours.
Thank you very much, Stafford. And I also wanted to thank you for all of your help putting this conference together, and your enthusiasm especially was really valuable, and really to everyone who helped. But you have been a great help and source of inspiration to me. So thank you for that.
Well, thank you.
And thank you also for all of the participants here on this session. I'm really happy to be with you this afternoon. In the student conference that took place this morning, we saw dozens of examples of the type of high quality student research that SSRIC faculty especially all hope to achieve in their classes. And I remember being on the awards committee one year and really noting that some of these faculty are able to lead students to good outcomes. Many students, you can tell they have the same professor. What's their secret? Do they have a formula for teaching students to do research? And it got me thinking about what kind of formulas to use. And so that's where this came from. I started thinking about how I can be a little more systematic in how I get students to do research. And of course, this is a panel on online methods. And the point I'd make here is that term papers are ideal assignments for the online environment. Students and faculty don't have to be physically together for us to give feedback on their papers and for them to revise it. And of course, student research is a high impact practice. Of course, it also takes a lot of work to advise students to do research. So one of the ways to make it a little easier, I think, is a replicate and extend approach. Because at least, even though replicating studies isn't easy, at least it's very clear what we tell students to do. We just say, "Did this study," and they've got their marching orders. And if they are able to replicate it, then it's often not too hard to extend it by modifying one line of code. I'm working on a project that provides analysis files in R and Stata format, and those are all on my webpage, and I'm discussing them in a book that I'm working on. I'll talk about at the end. So replication more and more is used in the classroom across the social sciences. These are examples from political science, psychology, and economics. My approach is really specific, and I have some suggestions for someone who might be considering adopting replication assignments in their class. First is to select the studies for the students. It is good if they do their own literature review. In that case, the faculty has to be very careful to approve the studies that they select so that they cover the right techniques. I also impose a specific restriction, which is that the data has to be public use microdata from IPUMS, and I'll talk about IPUMS in a moment, which sounds like a very specific restriction, and it is, except at the other hand, IPUMS is an amazing source of survey data. It has historical data going back to 1703 from over 100 countries, as you see here on the screen. So it actually does enable us there are a lot of studies that are candidates to replicate. This is the IPUMS webpage. I focus on data from IPUMS USA, which is decennial census data as well as American Community Survey data. This is the IPUMS USA page. Note there's a bibliography, and this has thousands of studies listed in it. It's a good source for finding good candidates to replicate. But once you know what data you need, you just click Get Data, and it is about as straightforward as I think possible. Students can navigate this. They have trouble sometimes, but they can navigate it. And so as you see, essentially you click the variables you want, you click the years that you want, you put them in your cart, and you check out. So a few other issues that come up when you have replication assignments with students is that sometimes the student may want to email the author of the study and ask if they can share analysis files. And I've decided that's not a good approach. In other words, there are several reasons why I wouldn't really suggest students contact authors. One of them is that actually having the replication files isn't as helpful as it might sound. And from a learning experience, it can be better sometimes if they don't have them. If it's an economic study, it was probably done in Stata. And I think for a student to translate Stata to another environment, R or SPSS or whatever, is a great learning opportunity and exercise. And for some students, just running replication files provided by the authors with the author provided data is a good outcome. But better yet is if the student downloads the raw data and replicates it with the data they downloaded themselves, because it opens up a whole world of extension opportunities. Whereas if you're using the author supplied data, it's much more limited. Finally, I tell students at the beginning of the semester, here's a paper you are assigned to replicate. But in fact, I'm pretty relaxed about the definition of replicate. If they reproduce a result perfectly, that's great. But many papers end up not looking that much like the original study. You know, it's kind of inspired by it in terms of the question or the years and the variables, but sometimes it ends up looking different, and that's just fine. I think that's part of the research process. So I mentioned that sometimes we do have replication files provided by the authors of the studies, and here is one place where you can find them. John and Ed mentioned ICPSR. This is a new initiative from ICPSR called Open ICPSR. And one of the things that authors can do is upload their research data and analysis files, including the one I've highlighted from the American Economic Association. Every article published in any of the journals from the American Economic Association is archived there. So here's an example of a study published in the American Economic Review. And by the way, this is in the Papers and Proceedings issue, which for those of you in economics would be my recommendation to use in your classes, because these are short conference proceedings, but they're high quality and the replication files are all online. So if you click that link at the bottom, you'll be taken to this page on Open ICPSR. And there's a lot of files. I mean, there's a dozen files here, but 2 or 3 of them are the critical ones. And the student could download these. They're in Stata format. Download the data, the do file, and run it, and that would be a good outcome. A better outcome would be if they use the author-provided data and coded up the analysis in R or another software. And then, as I mentioned, the best outcome is if they write the code themselves and use the data that they downloaded from IPUMS. And so, in fact, I've done that with this American Economic Review article I just showed you, and I published the results in this article that I listed. And I show students this so that they can see an example of how a project that started as a replication turned into an extension, and eventually what was used to create new knowledge. So I have used this basic approach in graduate classes, in upper division undergraduate classes, and also in lower division, basically intro stats type classes. And I have examples for each of these classes of one study, and I'll show you more later. The first one by John Winters is called "Is Economics a Good Major for Future Lawyers? Evidence from Earnings Data." And this study presents descriptive statistics. Using American Community Survey data, it focuses on the respondents who are lawyers, and presents the count and frequency of what was their undergraduate major. And so political science, I think, is the most popular one. And so it also calculates the average earnings of lawyers who have those majors. And I want to show you on the next slide an extension because, as I mentioned, once a study is replicated, it's often very easy to modify it in some way to create totally new knowledge. And in this case, a user can modify the occupation from lawyer to software programmer or dentist or whatever industry or occupation they're interested in, and see what are the most popular majors of people working in that field and what are the earnings for people in those different majors. But before I turn to that, I'll just mention two other ones. The Costa and Kahn study here in the middle is the study I showed you earlier from the American Economic Review. And the technique it uses is multiple regression. And so I think pretty much all intermediate statistics classes cover this, and it's a good example of using multiple regression to try to isolate causal effects. And then the final study I mentioned, I think I have used it in undergraduate classes, and I think it works very well for many students. Definitely a graduate class could use it. It uses a statistical technique called difference in differences, which sometimes is considered an advanced method, but I present examples of it in its most basic form, and undergraduate students, they do get it. I will just make one other note that when you look through studies that use the American Community Survey microdata from IPUMS, many of them do use the difference in differences approach. So it's a popular technique. Okay, so this is a table showing you an extension of that Winters 2016 study I mentioned on lawyer earnings. These are the 20 most popular majors among software developers and their average earnings. So you see that 28.6% of software developers, people who are currently working as software developers, were computer science majors, which shouldn't surprise you. But you also see in this table that social science disciplines are represented. Economics, psychology, and political science are all in the top 20. And this is a bit of a digression, but one of my hopes is that by using big data in the classroom, I'll provide some opportunities for students to learn how to work with large data sets so they can get jobs in data analytics fields that are popular right now. But I digress. This is an example of a study that could be used even in an intro stats class. And I want to turn now to talk about technology, because it definitely is a challenge to get students to use any software program, as we all know. But there are also some real benefits of the situation we find ourselves in now of having to be in an online-only environment. First of all, screen sharing is immensely helpful for teaching students programming. And I'm sure I'm never going to go back to the old days where I just demonstrate software in the classroom. Instead, it's very helpful for the students to actually see my screen, full view, and for me to be able to see their screen, to record those sessions. So even when we do go back to in-person classes, I'm going to keep making more use of screen sharing than I did before. Another option that we have is to use software installed on virtual machines, because the data that I'm using here is really, big and large data sets in terms of, it has millions of observations, even in just 1 year of data, and we're using 10, 20 years of data sometimes. So that's a challenge for students, and virtual machines can help. One free option, currently free, my guess is it won't be free forever, is called RStudio Cloud, and I'm going to demonstrate, show you a little bit of what that looks like in a moment. First, I'll just direct you to this blog article I wrote. This is an example of what are the most popular majors by occupation. And I have a video that I've made that I've linked to there. And I also have a link to the RStudio Cloud program. And this is what it looks like. You see that this is a web browser, and within that browser is RStudio. And RStudio is essentially an interface for using R. It just makes it easier to use in terms of having 4 different windows. So a student can type their code here in the top left window, or modify the code, and then click run. And that's how it works. And then they'll see the results down here in the bottom left console. The files are stored here in the bottom right. And the video I mentioned on my blog explains how to use that, but I just wanted to give you a sense of what using R in the cloud looks like. So many of the files, especially that use large data sets, I haven't found a good virtual machine to host them on yet, because RStudio Cloud, although it's free, it imposes moderate limitations on the memory. So I can't post the full data extracts from IPUMS to RStudio Cloud. Instead, the students have to download them, save them to their machines. But then the R scripts and also Stata do files are here. So this is my webpage, and I'll just show you a few. This first study I mentioned, we've been discussing. I list what are the course topics that it deals with, and then the data files in R in Stata format. This is the differences study that I mentioned, and you'll see there is a RStudio Cloud link to that. And I am updating these files, and will be updating them over the summer as well, but they are here now. And I hope that really with this presentation, my main goal is to try to inspire or encourage other faculty around the CSU to adopt a similar approach, because if we have a community of people who are using research studies in the classroom and replicating them, and they can encourage their students to share their replication files, and maybe they don't get all the way in one semester, but another student can pick it up the following semester. And that's great for student learning. It's also great for our disciplines. If more of the statistical research that is done is subjected to replication. Many studies don't replicate for a variety of reasons. It's good for the discipline to have a little more scrutiny on that. And then finally, it's good for us faculty who are using these methods in the classroom, because it leads to opportunities to do original research, to collaborate with students on research. So my point is, I'm really happy and more than happy to try to help anyone who might be thinking about using some of these methods. This semester I had 25 students in my econometrics class, undergraduate, introductory econometrics. Each of them were assigned a different paper, and I'll share these PowerPoint slides online and by email with anyone who contacts me. All 25 of those studies are listed in the notes section. So that's all that I have. I'd love to take any questions, and thanks again for being here. Really appreciate it.
Thank you, Matt. And before we begin the discussion, let's give Matt a round of applause.
Thank you.
Yeah, take yourselves off the mute, and a lot of great information.